The third method, as I said before, of estimating the sale price of a property is using discounted cash flow methods. Okay, here's our D, here's our C, here's our F. You started to learn about these with Professor Audet in his Mathematics of Money chapter. We're going to review this a little bit more in our next chapter. But for now, let me say a few things about DCF. Okay, one common discounted cash flow method is called the net present value method, which looks mathematically like this. And what it says in words is the net present value of a project is equal to the sum of each cash flow for the sponsor, for always one entity at a time, of this project, for the sponsor of this project, brought back to its equivalent at t equals 0. As you've learned in your Mathematics of Money chapter, you can't, when you're being careful and using discounted cash flow methods, you've got to consider cash as a function of time. So you can't add up cash flows to or from an entity, a developer, a sponsor, a lender, until you first brought them back to an equivalent time, say t equals 0. So that's what's going on here. Each cash flow for the developer of the project is being brought back to time t equals 0, the beginning of the project. Once we've done that, we add them all up. And now what do we have? We have a set of apples to apples cash flows. And if the sum of the positive cash flows for CAG is on this apples to apples discounted basis is greater than the sum of the expenditures on this apples to apples discounted basis, then that's a positive number. That means they've made money, okay? And that's what we call the NPV. The NPV is simply just the sum of all those discounted cash flows. If it's positive, it means they estimate the project will make money for CAG. If it's not positive, they don't. And the great thing about DCF that makes it so much better than cap rate is that we've got a set of future cash flows that we're looking at here, not just 1 year. So you can go out 5 years and say, well, demand in the first year is going to be pretty good, but in the second year it'll be more. We can raise our rates, we'll have a higher NOI, et cetera, et cetera, et cetera. So we can build a better model of the future with DCF methods. Okay, all the definitions for everything in this equation are down here. You're welcome to review them. We are going to cover them a bit in my next module, so if you want to wait, that's fine. So we're not going to do a DCF calculation right now. That'll come in the next 2 modules for this project. But just a few words on how we'd think about NPV. Okay, so from CAG's perspective, right, they would like the NPV to the project buyer to be as low as possible. So they'd like the buyer to make a mistake and get a negative NPV for the buyer. They're expecting what's fair is NPV is 0. That's considered the fair deal for the seller and the buyer. And if CAG is a bad negotiator, makes a big mistake and sells the property for too little, they're going to find the buyer has an NPV of greater than 0. Okay, so problems with DCF methods, NPV in particular. Why aren't we using it right now? It's very complicated. We need to review what you've done with Professor Audet before we get there, and we're going to need to learn a few more things before we're able to do this for real estate projects like this development project. And determining some of the quantities is complicated because now we're not just looking 1 year ahead. We got to look farther ahead, and the farther you look ahead, the more obfuscated and nebulous things look. Also, we're going to have to think about, from the buyer's perspective, they're going to sell the building in 5 or 10 years. What are they going to get to? That's even harder to estimate, et cetera, et cetera. So add it all up, DCF valuations we just don't use in feasibility studies. We just use gain and return. But we use them often, but not always, in financial plans, which we're going to get to in my 3rd module. Okay, so let's think about the overall thoughts on our analysis and our conclusions here. Okay, so our gain and return estimates for the comps method, I'm just going to jump right to return, which really tells us everything we need to know. All positive. Okay, and same thing with the cap rate method. Okay, all positive. always good to do at least these two methods, even in a feasibility study, because you might it's easier than you think to make a big mistake in one of these methods, especially the cap rate method. So if the two methods give you wildly different results, that's telling you you better go back and look very carefully at everything you've done. You probably have a mistake somewhere. Okay, but when you get similar numbers like this is looking pretty good here. So they're going to get a return if things work out as expected, even if market conditions aren't as great as they think. If market conditions are better than they think, they get a 10-11% return in a year. And remember, again, this is all no borrowing, 100% equity financing, which is always conservative. And also our tax assumptions were pretty conservative. If we got together with a real estate tax professional, we could maybe do a little bit better on taxes. Okay, so that's sort of the good. You compare these returns in 1 year, 6-7% expected, always positive, to a 1-year treasury, which at, for example, November of 2016 is paying less than half of 1%. Maybe a good place to put your money is to put it into this project and expect that you will do better. And some of the downside things for us to think about here are that we did do a pretty good job of estimating sale price in different conditions. We used two methods. We used the comps method and we used the cap rate method. And for both of those methods, we considered 3 scenarios. What did we not do for the costs we projected for this project? We did not do any of that. We just came up with one single cost estimate. We threw in a little number, possibly for cost overruns, but we didn't really seriously consider different scenarios for costs. Okay, so definitely the cost estimates could use some improvement. We didn't include variability, good situation, bad situation, expected situation, and variability synonym for risk. So we didn't consider risk, and it would be good to do that. But overall, everything said, I would vote that this project is definitely worth a closer look, worth looking further at it. And our next step for doing that is to develop a financial plan. And that's going to be where we're going. We need to do a little bit of review and a little bit of expansion of the mathematics of money and discounted cash flow project evaluation methods first, but then we're going to jump right back into Apex and do a financial plan for it. Okay, so what do I mean when I say financial plan? We want to improve on our feasibility studies. These are only for projects that have passed that first feasibility study hurdle, and we're going to look at the timing of the cash flows. In the feasibility study, we just lumped all the costs together. We didn't say when they happened. As you know from mathematics of money, cash is an exponential function of time, so we really need to consider it in time. Now we're going to want to bring in a lender, a construction loan lender, maybe a land lender too, and we want to see if we can improve our modeling of variability and risk, particularly in costs. Okay, so that's what's coming, okay? And in the next module, we're going to review some of the time value of money concepts that Professor Odell went over, and we're going to learn some new stuff about discounted cash flow methods for project evaluation. And after we do that, we're going to jump right back into Apex and look at a financial plan for Apex. So stay tuned. I look forward to seeing you in the next 2 modules. Take care.